Hi everyone and welcome to Docker Best Practices workshop, which will cover how to work effectively with Docker. So before we start, here is a quick introduction about myself. My name is Ahmed. I am a DevOps engineer and I am part of the infrastructure team at Camunda. I am interested in cloud computing and Kubernetes. Also, I am working with open source for many years in my free time. My favorite topics all the time are DevOps transformation, automation, and working with data in general. You can find me at LinkedIn or my tech blog, where I write some interesting posts from time to time. And given that this workshop is about do's and don'ts, here is the first example on that. You can find it on the right side. So here is the content of today's workshop, and we will go through them one by one in this workshop. So let's have a quick overview about today's workshop. In the first part, we will go through all practices, then get any questions you have and take a break. Then we will apply these practices in the second part by Dockerizing an application, and we will make sure it follows all the practices we have here today. Finally, we have some time for discussion. And as mentioned here, this workshop assumes that you have already some knowledge of Docker, or at least Docker basics. So I will not really talk about Docker basics here, but we will have a quick introduction first as a refreshment. So let's have a look on some basic concepts, which are containers, Docker, and Kubernetes. I will assume that everyone knows what are containers. So Docker is a software to build and run containers, and Kubernetes is a platform that orchestrates containers workloads. Kubernetes is not covered in this session by any means, but if you want to have some hands-on experience, please check the Kubernetes workshop by my colleague Shaima, and you can access it in Camunda Academy. Now let's check three important concepts, which are Dockerfile, Docker image, and Docker container. So what you need to know about this is that Dockerfile is used to create Docker image, and the Docker image is used to create the Docker container. Later, we will have more details about those concepts and their best practices, but let's start with some essential practices. The essential practices are simply must do, like you should do them for sure. And they are applied like all the time, I would say. And here is the first one. Use Dockerfile linter. Like every linter, it will help you to follow Docker best practices by default. You can use hadolint via CLI or IDE. It already has a plugin, for example, for to make it work with VS Code. So by doing this, you will avoid at least 50% of the Docker issues. It's a great tool, to be honest. You should have it for sure. On the right side, you can see an example of hadolint hints. Check Docker language specific best practices. So there are many best practices actually, and different kind of them. So besides the general best practices, also there are some language specific best practices. Create a single application per Docker image. Okay, we are in 2021 and this point could be pretty obvious. However, I still see it till now, especially in the enterprise applications. So if you are going to Dockerize some applications, make sure that single Docker image has a single application. And it's not only about the application itself, but also about the processes. Multiple processes within the container usually make a lot of problems. Just avoid that as much as possible and you will be fine. Create configurable ephemeral containers. Again, this is kind of general practice, not especially for Docker. and containers, but simply if you follow the 12-factor app, you will create a good Docker image and Docker container. Now let's take a look on the Docker image practices. So before we go any further, let's take a moment to understand how Docker image is structured. If you ask me, this slide is really important. It's the most important slide here, I would say, because a lot of confusion comes from not getting the structure of the Docker image. So the first thing you need to know or need to remember about that, Docker image is made of layers. And each instruction in the Docker file, like env, add, run, is a layer in the Docker image. And each layer is immutable, which means it's read-only. And you cannot edit parent layers, but just append to them. Please note that only add, copy, and run instructions can create file system layers, and they can increase the image size. The rest are creating intermediate layers, or simply you can say it's soft layers. They are embedded in the image metadata. Hence, when you creating the Docker image, if you created a file by one of the Dockerfile instructions and trying to remove it in the next instruction, the file will be still there. It will not be removed. It just removed from the surface of the image. It's still inside embedded in the image. So if you want to avoid saving data in the image, you should make sure to remove them within the same layer, or don't put them in the first place. We will have more details in a minute, but just remember, Docker images are immutable. You cannot change them later. Now let's back to the Docker image practices. So here, always use an optimal base image. Optimal image here means it's in a good quality and it's well designed for the use case you have. For example, if you are going to run a Python application, don't use a generic image and then install Python and all of that, but use an image made for Python. Most of the time you will find a good fit for your use case, instead just using a generic image. Pin versions everywhere. Please never ever use image without a tag or with the latest tag. You will really regret it sooner than later. The same goes for the tools and the dependencies installed within the image. In the most cases, pinning minor version should be fine, but for critical components, it's better to pin up to the batch version. As shown in the do example here, both the image and the installed libraries are pinned, so you are certain about which version you will get in your image. Create image with the optimal size. Here again, I use the word optimal, unlike many other recommendations which use smallest. Yeah, as a rule of thumb, smaller Docker images are better. However, sometimes we need to balance between build time and deploy time, which is basically affected by the Docker image size. My question always, is it okay if we save like a couple of megabytes, but the image takes 30 minutes to build? For me, that's not okay. So in the examples, you can see that Docker Alpine image size is 3 times the other image, but the build time for Alpine image with Node installed on it is 3 times the Node Alpine image. So we need to find the balance here. We need to find what works for us. Sometimes the smallest is not the best. It depends on your case and how you are doing things. But yeah, smallest better, but not always the best. Use multi-stage whenever possible. In my opinion, multi-stage is one of the best Docker features. It's super useful for many use cases. Multi-stage means you can split your Docker file to stages, instead build the whole file at one shot. One of the most known use cases is creating a stage to build the binaries and another stage to run it. So you have the build stage with all dependencies and build libraries, and another one just clean, just to run it. For example, this works great for Golang, for example, and compiled native compiled languages. So the final image will be small and clean. And by the way, you can copy binaries from any image, not necessarily from your build or that one you build. For example, you can copy a tool from another image, so you don't really need to use curl or wget to download that tool. So this feature is really helpful to copy files from another image. Avoid any unnecessary files. Just as mentioned before, minimal image size is important, as well as short build time. Any extra file could increase either of those. So always try to specify the files and paths are needed to make application work. Also, you can use .docker ignore file to filter any unwanted patterns. It works more or less the same as .get ignore. Now let's take a look at the security practices. And here is the first one. Always use trusted images. If unsecure Docker image is used, then every other action will be unsecure. Or in other words, they will be the fruit of the poisonous tree. So always use images from trusted repositories, and also you try to use, of course, official images whenever is possible. And for critical components, it's even better to avoid using public images. You don't know who has access to those images and what could be changed there. So could be overwritten anytime. And you get some malicious software if they are hacked or something like that. Finally, the other way around, use Docker Content Trust, which is a way to sign your images. So, for example, no one hacked them somehow or so. Never use untrusted resources. Using a trusted image doesn't help if you using untrusted resources in the image itself. For example, some of the build scripts could be downloaded from the internet or so. So if needed, always use resources from trusted sources. And when you download something from Git repo, for example, GitHub or so, always use git hash to make sure you will get what you really expect. And don't rely on the git tags because they are mutable and could be overwritten easily. Actually, if you can avoid all of that and just copy the script to be part of your repo, that would be even better security-wise. Never store sensitive data in the image. And this one of important topics also. I have seen that mistake a lot. As mentioned before, each instruction in the Docker file is translated into a layer in the Docker image, and Docker image layers are immutable. That means also if a file created in one of the Docker image instructions, it cannot be removed by the next instruction. And the next instruction will just remove it from the image surface, but it's still there, embedded in the image. So for runtime, when the container is running, use envs to access the sensitive data. And that has been used for a while and it's fine and working fine. For the build time, when you're building the actual image, you maybe need to access some protected external resources like npm registry or so. For that reason, first of all, never use arg instruction to pass secret during the build time. The secret will be saved in the image as a layer, so could be retrieved again. In that case, use the mount feature from Docker build kit, and in the example, I pass the GitHub npm token from the host to Docker build, and unlike using arg instruction, it will not be saved in the image, so it's safe to use. Actually, BuildKit has many other options. Check them for advanced use cases if you have one. Use a non-root user. By default, if you didn't set the user for your Docker image, then Docker will use the root to execute commands inside the container when it's created. And of course, using root, it's a bad practice and always has a security risks. So always use a non-root user to run your container application. Yeah, I know there are some cases where you really need to use the root user, but by default use a non-root user, simply unless there is a good reason not to do so. And maybe that sounds obvious, but just to make it clear, Docker will not create the user for you, and the user must exist in the Docker image system. Scan image vulnerabilities. And here the last security practice, which is helpful to early detect security issues. So use vulnerability scanning tools to detect exploits in the image libraries and integrate one of those tools with your CI pipeline or your Docker registry. Nowadays, there are many of them, open source, SaaS, and part of the major cloud providers. Now let's take a look at some general practices. Leverage Docker build cache. This is actually one of the interesting topics, and as I mentioned before, Docker image is made of layers according to the Dockerfile instructions, and when there is no changes in the layer, it's not built again, but Docker reused the last one, or what's cached already, and this known as Docker build cache. However, if there is a change in one of the layers, its cache is invalidated together with all sublayers or next layers, even those layers haven't been modified or changed. And this actually leads us to the next slide. So to get best out of the Docker build cache, you need to put less frequently changing instructions at the top of the Docker file and more likely changing instructions at the end. By doing that, you will hit the cache more, and you will avoid unnecessary cache invalidation for unmodified layers. In the example, if you put the copy first, any change in the source code will invalidate the run and env layers, which are unrelated to the code itself at all. Avoid system cache. And actually, unlike Docker build cache, you need to avoid system cache. For example, most if not all Linux package managers have a caching mechanism to avoid retrieving metadata when they are retrieved recently. So actually system caching is designed to speed up things that used frequently, but within Docker, each build is actually independent. So system caches are not helpful at all. Actually, it's bad for Docker images because it increases the Docker image size for no good reason. So always disable any system cache like package manager caching and so on. And here you can find one of the examples, but probably there are more to disable depending on the system. Create a unified image across environments. We already have talked about multi-stage feature and how useful is it, but in the past, before the multi-stage, usually people used to create different Docker files per environment. So you see like one for development, another for stage, another for production, and so on. And by doing that, you will have unexpected behavior in different environments. So always try to build your application image the same way for all environments. And as you can see in the example here, the same Docker file is used for different environments. And it's always a good idea to use the cleanest and the smallest stage for the other environment, or as a base for the other environments, as shown here. And if the multi-stage is too simple for your use case, you can always check the advanced options in the Docker build kit, which gives you more control over the builds. Use ENTRYPOINT with CMD. Let's finish with this simple but useful practice, which is super helpful when the image is used in Kubernetes. So either of ENTRYPOINT or CMD could be used independently, but it's better to combine them together if your application customizable via arguments. So use ENTRYPOINT for the main command and CMD for the default arguments. By doing that, you will have the option later to customize only the arguments without overwriting the actual command. If I need to customize some arguments, why I need to override the ENTRYPOINT? That was like extra unnecessary work. So next steps. Now you know more about Docker best practices and how they can affect many aspects of working with Docker. So you can do one or more of the following. First, start applying them in your latest project. Second, integrate Docker linter with your local IDE and your CI pipeline. Third, get more hands-on experience, and there are many scenarios on Katacoda for different levels. They are really helpful. Also, you can get into some advanced topics like using DCT to sign your own Docker images, and I highly recommend to take a look on Docker Image Kit. It's faster and it provides many great features. Finally, maybe you also want to know that Docker is not the only container system there. It's good to know as a general knowledge. You don't really need to go too deep into that. And here are the references. And that last reference is really great to know more about practical Docker topics. And it would be great to share your favorite best practice if it's not mentioned here already. Or for sure if you have any questions. Thank you.